Hi, this is a walkthrough of some notes for the two types of energy. So pause the video whenever you need to so you can fill in the highlighted areas. They should match the ones that are in your note guide. And we'll go through them right now and then do a couple problems to practice. So we're learning about energy this week, and there are two kinds of energy: potential and kinetic energy. The equation for potential energy is, I missed this part. Potential energy is an object's energy stored due to position. So if you raise something up high, that means it has a lot of potential energy. Think of like a roller coaster at the top of a big hill. Okay, there's a lot of potential energy there. If you gave it a little push, it would start to go down and lose some potential energy. But having all that mass up high is potential energy. Or like a apple that falls from a tree. When it falls, it hits you on the head. It has energy because it's up high above your head. So higher elevation means more potential energy. The equation is very straightforward. Potential energy is equal to mass times gravity times height in meters. So here the mass is in kilograms. Gravity is a constant. You always use 9.8 meters per second squared. And h is the height in meters. For a sample problem, we have one right here. A book placed on the top of a shelf of a bookcase has a mass of 4.5 kilograms. The book on the top shelf is 2.4 meters above the ground. How much potential energy does the book have when it's on the top shelf? So from the equation above, potential energy is equal to m times g times h. And you can plug the numbers right in. The mass is 4.5 kilograms. Gravity is a constant. It's 9.8 meters per second squared. And the height here is 2.4 meters. So when you multiply all three of those things together, you get 4.5 times 9.8 times 2.4. And energy is going to be in joules here, so I got 105.84. And the label will be joules for energy. For those, you're always going to have a height, so that's kind of what you're looking for, 2.4 meters above the ground. So keep your eyes out for those. The other kind of energy, if you bounce back up here, is called kinetic energy. Kinetic energy is an energy of an object due to its motion. Like if you are in a car, you have a lot of energy because the car is moving. Or imagine the roller coaster that was on the top of the hill, now it's at the bottom of the hill. Well, taking all of its potential energy and turn it into kinetic energy because it's moving really fast. So the equation for kinetic energy is 1/2 mass times velocity squared. So the mass has to be in kilograms, and the velocity has to be in meters per second. And you square the velocity when you plug it into your equation. So a good example would be this bottom problem here. A ball is rolled across the floor at a velocity of 4.5 meters per second squared, and the mass of the ball is, 4.5 meters per second. The mass of the ball is 2.5 kilograms. What's the ball's kinetic energy? So kinetic energy equals 1/2, just 0.5, times mass times velocity squared. So when you plug those in, you would have 0.5 times the mass is 2.5 kilograms, and the velocity is 4.5, and you would square that number. So when you plug it in, you can start with a square if you want. It'll work out either way. 0.5 times 2.5 times 4.5 squared. There you go. And I got 25.31 joules for its kinetic energy. It's important to remember, if we jump back up here, that energy is always conserved. So it can be converted from one form to another, but it's never lost. It can be lost like by friction and stuff, but it just never disappears. Okay, you don't take energy from nowhere or make it go to nowhere because energy is always conserved. So again, the roller coaster is a really good example. You have a lot of potential energy at the top of the hill, and as it rolls down, it converts all of its potential energy into kinetic energy. Okay, there's the notes on potential kinetic energy. Thanks for watching. Like and subscribe. Bye!